All right, so we are going to do the solution to SOA problem number 66. And this problem, they want us to find the they want us to find the sample size so that the standard deviation of expectation of x is less than 0.05. Or one way to think of this is the variance of x is less than 0.0025. Sorry, this is the standard deviation of the expectation of x. And so to do this, we first need to find our sample variance, and that is going to be equal to the sum from I equals 1 to n of 1 over n minus 1 xi minus x bar squared. And this is just a formula that's from a basic statistics class. And to use this formula, we need to find our x bar, which is just the sum of all our values over the number of values, which is 3. Okay, and now to calculate our s squared, this would be 1 over 5 minus 1. Then we have 1 minus 3 squared plus 2 minus 3 squared plus, and this goes on until we get to 5 minus 3 squared. And then our s squared is 1 over 4 times 10, which is equal to 2.5. Okay, but we want to find the variance of the sample mean. So the variance of the sample mean is the variance of our variable over n. So we want our 2.5 over n to be less than 0.0025, which is again the variance from up here. And to do that, we just need to solve this, so we get that n is greater than 2.5 over 0.0025, which becomes n is greater than 1,000, or answer choice E. All right, our next problem is going to be SOA problem number 81. And in this problem, we are told that the probability that y is an exponential distribution with our variable equal to 0.5, and the probability that is true is 0.3. And then the probability that y is a uniform from -3 to +3 equals 0.7. And then they want us to simulate a random number from this distribution. So first we need to find whether or not our value is from an exponential distribution or a uniform, and then we need to use the inversion method to find out what our value is. So we're given two values here from a uniform distribution, and those two uniform values are 0.25 and 0.69. And we use this first value to find out which distribution, and then we use the second value to find, or in the inversion method, to find what our simulated value is. Okay, so for 0.25, since 0.25 is less than 0.3, which again is equal to the probability that y is an exponential distribution, we know that our value comes from the exponential distribution, with our value equal to 0.5. Okay, so now we just need to use the inversion method with this distribution. And to do that, we say that 0.69, which was our second simulated value, equals the probability that y is less than or equal to x. And then we plug in the fact that it's an exponential distribution, so 0.69 equals 1 minus e to the negative x divided by 0.5, which becomes 0.31 equals e to the negative 2x. And then we get negative 1.71183 equals negative 2x. And that was just me taking the natural log of both sides. And then in the end, we get x equals 0.585, or answer choice C. Okay, so we're now going to do SOA problem number 83, and this is another simulation problem that uses the inversion method. But to use the inversion method, we need to have our cumulative distribution function. So we're going to take the probabilities that we're given and find our cumulative distribution function. Okay. So I went ahead and found the cumulative distribution function for all values. So the probability that we don't find any treasure is 0.8. So that is for x is less than 1,000. And then we have the probability that we find some treasure between x from 1,000 to 5,000 is 0.8 plus 0.2 from, or x minus 1,000 over 4,000. And that's from 1,000 to x, or when x is between 1,000 and 5,000. And I found this just by realizing that it's a uniform distribution function, so I just treat it like a normal uniform distribution function, but I had to remember that it was only for when x is between 1,000 and 5,000. And then obviously it's going to be 1 when x is greater than 5,000. Okay, so we're given two simulated values and we want to find the average of the two. So our first simulated value from 0 to 1 is 0.75. So then we go and we plug this in and we realize that 0.75 is less than 0.8, which means that no treasure was found. So our value is going to be 0. Okay, and then our second value is 0.85. And since 0.5 is greater than 8, we're going to use it in this distribution. So we simply plug 0.85 into our distribution function, cumulative distribution function. And this is again using the inversion method. So we get 0.8 plus 0.2 equals x minus 1,000 over 4,000. And then we're going to want to solve for x. And subtracting 0.8 from both sides gives us 0.05 equals 0.2 x minus 1,000 over 4,000. And then with a little bit of manipulation, we get, in this case, x equals 2,000. And since we need the average, we just want to average 2,000 and 0, since that was our first value, which is, of course, equal to 1,000, or in this case, answer choice B.